Hey, AP Physics students, here is another installment of the hints for textbook assignments. This is T6.3, and we're talking about page 204. Really, 204 and 205 is the emphasis here. These are very important questions, and so it has to do with conservation of energy. Even though we're doing simple harmonic motion, remember that the force to compress the spring, Kx, produces a potential energy of the spring, so F equals Kx, and also, but the main thing is that the potential energy of the spring is 1/2 Kx squared. So if you look at problem number 24, the archer pulling on the spring, and if it acts like, well, it's a bow and it acts like a spring, they give you the spring constant of 425, and they say, what is the potential energy? So that's a very easy solution to part A. Then when you do part B, they're asking the question, how fast is it traveling when it leaves? So this is conservation of energy. Remember that the total energy will stay the same, and so the change in the potential energy is the same as the change in the kinetic energy. So all of the energy you get from the potential energy turns into kinetic energy, and you can solve for V. Very gentle. A little tougher question on number 31, but possibly even more important. On this one, what you've got is a stapling gun. And when you pull the trigger of the stapling gun and the staple leaves, what you've got is the total energy at the very beginning. As we've talked about, the total energy stays the same in all circumstances. So the total energy at the beginning and the total energy finally is the same. The way I always solve this is to place an equal sign in the middle. And so what kinds of energy are at the beginning? Well, it's not moving. The ram is not moving at the beginning. All it has is some spring energy. 1/2 Kx squared, the I for the initial compression. And it is up at some particular height, so it has not only the spring energy, but the gravitational energy. And then when it leaves, it has a different compression. It has a different height, but more importantly, it has now kinetic energy that it didn't have before, 1/2 mv squared. Hopefully that'll be enough to help you solve this problem with strength. Thanks.